morning, everybody. Very happy to have the first talk today. That's the first time I do the first talk at any conference. And it's a special conference because the conference is celebrating the 10th anniversary and also the 30th anniversary of Java. And I'm talking about the return of the full stack developer. And with full stack developer, I mainly mean full stack development, full stack web development. So client and server, I don't refer to DevOps and all the operation stuff. It's just about software development. About me, I also have a 30th anniversary this year because I'm working in software industry for already 30 years. I'm doing mainly Java since year 2000. I'm an independent consultant and teaching at universities. And I'm also a colleague in the Java user group in Bern in Switzerland. And I'm a passionate full stack developer, so I like my job. If you have questions, you can ask them at the end or during the presentation, doesn't matter. There is also an app, slido.com. You can scan the QR code and then you can enter your questions during the talk in the app, and I will answer that questions at the end. So maybe start with the rise and fall of full stack development. Because if we move back in time, I started in 1995. I was working with dark mode applications back then. And I was working on IBM mainframe computers doing software development with COBOL. And back in the days, we all were full stack developers because there was no front end, right? Because this was server-side rendering. So every developer had to do everything in the application. Later on, unfortunately, I didn't find any better screenshot, but this symbolizes a Swing application. We moved in the Java field to AWT, to Swing, and again, we were doing full stack development because we were all Java developers. And then it changed a bit in terms of technology. So this is a screenshot from the first ticket job of Swiss Railways, where I was one of the architects more than 20 years ago. Swiss Railways was the second railway in Europe providing online ticketing, and we were building web applications for more or less the first time, and this was Struts. Someone remembers Struts from back in the days? I realized that this framework still exists, so it's not dead, it's still maintained and you can use it. It's probably a bit different from what we were using back in the days, but even there we were full stack developers because we were working on the whole ticket job application. And after that we had, at least in business application development, we had a little shift back to desktop applications. And this is a very recent screenshot. You can't read it, but this screenshot is from the 27th February of this year. So this is my current project, or one of my projects. I'm doing modernization of software, mostly in the e-commerce or commerce, wholesale, retail industry, and this is an ERP system. And it is built with Eclipse RCP. Who remembers Eclipse RCP as a platform, not as an IDE? So it was very popular because you could create quite easily applications with it. It has some flaws. It was difficult because of OSGI to manage, but it serves as a application platform. And then we had the year 2010. Does anybody know what happened in 2010 in terms of software development? Any ideas? Angular was introduced. And as Google announced Angular, and they promoted the new way to work with Angular, a lot of companies, at least in Switzerland, moved to Angular as well. So Angular in the year 2010 to probably 2015, a lot of companies produced new applications with Angular, and in Switzerland Angular became like the government front-end framework, so to say, because in the German-speaking part Angular is very popular. in the English-speaking part of the world, and in the rest of the world, maybe React is much more popular. But that's probably because, at least in Switzerland, because of the very early adoption of Angular in business application development. So what we usually have today is something like that. So we have a single page application framework, Angular, React, maybe Vue. There are plenty others of these kind of applications. But what's important to see in that picture is that we made a shift back, because this is not server-side rendering as we had with struts, right? So this is client-server programming as we had in the 90s. And client-server programming comes with some challenges. First of all, we have a split. So we need an API to access the server. And the question is, how do we access the API? Or the other question is, what is the API? Is it a RESTful API? Is it GraphQL? Is it something else? And on the other hand, how do we build that stuff? Because as a Java developer, for example, I don't know the JavaScript ecosystem. And so I have to use a completely different ecosystem, a completely different tool set, and I cannot stand with my tools that I already know. And on the other hand, we have validation twice, right? Because we have to make sure that the user enters just validate on the client side for convenience of the user mainly, but we also have to validate the same input on the server side because we are not sure who is using our API maybe. So we have to make sure that the data is valid, and also we have to check security, for example. And that's the way people were building applications, I would say, from 2010 until now. And what happens was not only back to client-server applications, because we already had that, like with Swing or Eclipse RCP and other technologies in the Java ecosystem, JavaFX. For example, we also do client-server application, but now we have two different ecosystems. And if you look at, for example, conferences, tech conferences, you also have this split, right? You have front-end conferences and you have Java conferences. And Java conferences usually are more talking about the back-end and not about the front-end. The same is true for domain-driven design, for example. If you listen to a domain-driven design talk, then you will notice that the person speaking is only talking about the back-end. He's not taking the front end into account, and that's probably mainly because we have that split here, right? So we introduce like a split between front end and back end, but the application as a whole is one thing, so there's no split, and the user just sees the front end. The user will never see the back end. And in the last few years, there were people trying to revive the server-side rendering stuff. Maybe you heard about David Henmeyer Hansen. He's from 37 Signals. He introduced Ruby on Rails. Who remembers Ruby on Rails back in the days? And he was talking a lot about, first of all, monolithic development, and then also about server-side rendering. And there was a framework introduced. I will also give you a short introduction about that. It's called HTMX. Does somebody remembers or knows already HTMX? This framework also had a very great, or the developer behind the framework has a great social media presence. So he's very good at doing marketing. And so people were thinking about maybe we could go back to the server with the UI because this may solve some problems. And that's what I call the return of the full stack developer. But the full stack developer has some, how should I say, maybe disadvantages, or people say, hey, that's jack of all trades and master of none. So you have to know a lot of stuff, but you will never be an expert in the things that you are doing. Now the question is this really relevant or not? Let's take a look. First, what are the advantages if we are doing full stack development? In my opinion, it improves efficiency. First of all, because one developer could handle a complete feature from UI to database, and that's usually faster, especially if you're doing rapid prototyping or doing MVPs. You are much faster because you don't have to care about the API. Because if you're doing client-server application programming, then you have three parts. You have the client, the API, and the backend. And so you have to test every part in your system, and probably this is not as efficient as it could be. On the other hand, and that happens a lot, if you have a team that is split into front-end development and back-end development, and if you have that, you have a lot of communication, and communication reduces speed again, because maybe you have to wait for the backend if the API is not what you were needing in the front end, for example, or the backend developer has to wait for the front-end developer to tell him, yes, the API is exactly what we need, for example. And what happens then is very often a problem that maybe the backend developer starts first and he creates an API, a general purpose API, and then maybe a sprint later the front-end developer comes and looks at the API and says, oh no, that's not what I need, but we don't have time to change that, so I try to work around. And this gives a lot of issues probably also on the API side. But that's not the topic of my talk. On the other hand, we also have a simpler debugging setup because we are on the server side, right? We can just use a debugger. We don't have to start two application parts. And in my opinion, it's more fun and satisfying if you're doing both. Because did you ever get a round of applause if you created a beautiful SQL statement? No. So if you're doing a review, if you have a Scrum setup, for example, and you have a review meeting, usually the front-end developers can present their application, and the users will see that and think, oh, that's beautiful, that's exactly what we need, or maybe it's another way around. But as a backend developer, it's usually not that satisfying because there's nothing to show, right? And in my opinion, this is an advantage as well. Now let's come back and look at this jack of all trades, master of none problem. Because one of the disadvantages for sure is you need a bit broader knowledge. But that really doesn't mean that you have to be an expert in all parts of the system, right? Because usually if you start a new project, you have to do kind of upfront architecture work in terms what frameworks do we want to use, how do you want to use that, and then you have to kind of create a standardization of the things that you want to use, and that means you just need one expert of front-end and back-end development. Not the whole team has to be experts, right? But at the end of the project, maybe after 2 or 3 years, most of the developers will be experts in a certain field anyway. So that's why or how we come from a junior to a senior developer at the end. But one problem maybe is it can be overwhelming to do both. And the specialization may be slower because you cannot concentrate on a single thing. But it really depends on the size of your project and on the size of your team. So I work for many customers in Switzerland, and some have just very, very small teams that are very often small, medium businesses. They don't have even the ability to have front-end and back-end specialists because the team is not big enough, right? And then we have customers that are huge and they have specialized front-end and back-end teams, but even there, if you mix the project, you can have both in one team. So now, if we could agree that we want to start full-stack development, we have to have a look at the frameworks. And on this slide, there are just a few frameworks that are somehow related to web development with Java, but there are many more, right? There are plenty of web frameworks because building a server-side rendering web framework is not that hard, and that's why there are so many of those. I created a selection. I will come back to that later on, but first we have to have a short look at front-end styles. And here we see that we have kind of two styles. We have the server-side rendering, traditional page lifecycle, as it's called here in the pictures. So we have a request to get an HTML page back, which was rendered on the server. Then the user interacts, and each interaction may require, for example, submission of a form. That will be a post request, and again, HTML is returned, right? So that's Spring MVC, Jakarta Faces, Quarkus with Qute, stuff like that. And on the other hand, we have the single page application, and interestingly, there is a framework that I will show you today. It's called Vaadin, and Vaadin at runtime is a single page application. So it has the exact same page lifecycle like a single page application. You have like a single HTML page you get back, the so-called shell, and from there on you just interact with the server and get, in that case, also JSON back, and the JSON will be applied to the document object model, and this will re-render the page somehow, right? So these are the front-end styles, but there is another distinction between the server-side rendering frameworks. And the point here is you have to choose a side if you want to be on the bright side or on the dark side, because there are two mainly more or less completely different ways of building applications with server-side rendering. One approach is called component-based approach. So we have Vaadin, for example, on that side, and on the other hand we have Jakarta Faces, or JSF as it was called in the beginning. Both of these frameworks have components. What do I mean with a component? With a component I mean a real UI component, like a text field, or you have a table, or you have a tree, or you have a combo box, and these are components that are not just template-based stuff, but these are components that also have logic and events. On the other hand, we have this model view controller style. We have, for example, Spring. Usually people are using Timeleaf, for example. I will show you an example with JT. That stands for Java Template Engine, because this is the faster way of doing server-side rendering. And we have also Qute from Quarkus. Qute stands for Quarkus Template Engine. So what are the benefits of component-based UI frameworks? It depends on what you're building. So usually I'm building so-called business applications, usually also with like kind of a B2C, so a customer-facing part, like a web shop, for example, in e-commerce. But usually I'm building internal business applications that are mainly used by a relatively small number of users, right? But they should more or less look all the same and behave the same. So if you're in a, for example, in an ERP system, you have product management, you have customer management, you have supplier management, you have a lot of management-like applications, and there it's very handy, or it comes in very handy if the whole applications look the same and you can have reusable components. The problem with component-based UI frameworks, especially if you use that on the server, is you have state on the server. Because somewhere you have to have the component tree, right? So if you're using Angular or React, the component tree is in the client side. But if you're using Jakarta Faces, for example, the component tree, if you have, depending on the scope that you're using, is on the server side. So this requires usually more memory per session. And you also have to take care, if you're doing horizontal scaling, that you always go to the same node, or you have to somehow synchronize the session state. But the point of the component-based UI frameworks is it's, in my opinion, the better choice for Java developers, because sometimes you already have this UI knowledge, especially if you're older like me. You already did Swing development or JavaFX and stuff, and that's exactly the same that you could do on the server side. Also, if you're doing component-based application development, for example, with Angular or React, you also already know the components. And finally, you don't need to know HTML, because the HTML is not your part. You're not programming in HTML. You do maybe some template, we will see that, but you're not doing HTML development at all. So maybe why components here? That's the design system of the current project I'm working in. So we started building a design system. A design system means that's look and feel plus components, right? So including documentation, how to use the components, when to use certain components, for example. And we're doing that because we are modularizing a huge ERP system into smaller parts in so-called self-contained systems, and we want to have each application part look the same and behave the same. And so that's very important that we have those components. And components, if you're into Java development, for sure we have Vaadin with web components, so that's a screenshot from Vaadin. But if you did JSF or Jakarta Faces development in the past, you may know Prime Faces. And Prime Faces is probably one of the biggest libraries that you can have for UI development. By the way, Prime Faces not only exists for JSF, so that was the origin of Prime Faces, but there's also Prime NG for Angular and Prime React. And they're working on a new framework or a new implementation. It's called Prime Web Components or just Prime Components. And these will be web components. So web components is a standard, by the way. You can enhance each HTML page with custom-made components. You just need to write like a template and some JavaScript code to glue things together. And then you're ready with components. The other approach that the other frameworks are taking is, I call it template engines. And you have like a traditional HTML-like template. So usually it's some template with some expression language where you can bind data from a model to the template. The good thing about that is that you don't have state with such applications, and if you need state somehow, you should usually try to integrate it into the HTML page or somewhere else, so that you don't need any state on the server at all. For that, I created a small project. It's on GitHub. CMACH is my username. It's called Full Stack. And you can go there and find the project. I will not go into the details, but I created the same application with 4 technologies, and therefore we have 4 projects. So I created one with Jakarta Faces, I created one with JTE with Spring, and one with Quarkus and Qute, and one with Vaadin. By the way, Faces is neutral in terms of runtime, so in that case Jakarta Faces runs on Quarkus, but Jakarta Faces traditionally comes from the Jakarta E, so you could use it Wildfly or Glassfish, or you can even use Join Faces. That's a open source project that integrates Jakarta Faces into Spring Boot, if you like to do that. So these are the projects. They are all Maven based, and they all have the same structure, more or less. So let's maybe start with that one. It doesn't really matter. So we have like a domain package, and in the domain package we have a product. Product data is more or less like the repository. It's all in-memory data, and then a product service that we need to save a product, find a product, or find all products, and maybe count the products. And then we have a website. This one is the Vaadin application, and we can say, for example, here say hello, and we also have a list of products where we can select a product and, for example, change the stock, save that, and this will saved here or refreshed in the database table. And this is all the same. Also for Jakarta Faces, we have the products here where we can scroll. We have JT where we can scroll, and finally we have Quarkus where we can scroll. So the Quarkus and the JT application look the same because I use the same CSS. Faces looks different because it's Prime Faces, and Vaadin looks different because it's Vaadin, but it doesn't really matter, right? And you could even style that every application looks similar, but I didn't have the time, and it didn't help to explain the frameworks. So maybe let's start with Vaadin. I go back to the slides because it's easier for you to see. Vaadin is really about UI programming. So we have a route. The route is just at which path we will find the view here. For example, at the root path, Then we have a constructor, and we create a text field. We add a button, we add a click listener, and finally we add the text field and the button to the UI. Right, so it looks familiar to everybody. Already did that. And here we don't have any HTML. So how does this work? I tried to, or this is an old diagram, but I think it's still useful. Maybe just look at the left-hand side of the diagram. The important part is that you have web components. So each application component of Vaadin is a web component and is used in the client side because, as I said, it's like single-page application programming. And Vaadin, the real name of the Java framework is Vaadin Flow, and Flow is the component that is communicating between the client side and the backend side, right? And on the backend side, we have a component tree, like we built the component tree as we've seen before, and then we have a synchronization between client and server. And the benefit of that architecture for sure is you can directly access the backend from, or the backend, you run it maybe in the same application. You can integrate the user interface code with the business logic or the persistent logic, depending on what you want to do, right? Then the other framework is Jakarta Faces. Jakarta Faces consists of two parts. Usually you have a template, and the template looks like HTML, but the input text and the command button, so everything that has the H prefix here or namespace is JSF component. So you don't use HTML components like an input field or a button. You use components from Jakarta Faces. And then you have this expression language here with the hash sign, where you can access, for example, a value or bind an input text field to the name field. And then you also have, for example, a method where you can use to say hello. And on the other hand, you have a so-called backing bean that has a certain scope and has the method and the value inside. Now, who was using JSF for Jakarta Faces or still using it currently? Not so many, because there is something that people didn't like very often about Jakarta Faces. That's the life cycle. Because if you're doing this component-based approach, there need to be a life cycle to restore, for example, the component tree on the server, depending on the request. And then there is a lot of convenience. For example, you have transformation or you have validation in the process that will help you. For example, you can integrate Jakarta Faces with Jakarta binding, with Jakarta validation. And then you have the validation also based on annotations, for example, in the UI. And to do that, there need to be kind of a life cycle. By the way, you could also omit the template here and directly use the Java classes to build the application. No one does that, but that's a possibility that you have. So these are these two frameworks. And on the other hand, we have Spring MVC, for example, with JT, and this is traditional model view controller, right? We also have model view controller in Jakarta, by the way. There's also a Jakarta E specification called model view controller. And here we have a form. So all that you see there are standard HTML tags. So there's no web components, no special component thing. So you have to build your whole application out of templates. I know there is Tailwind CSS. A lot of people are using that. Does anybody know this framework? It's like Bootstrap, but on steroids. But the problem, if you're building application with template-based approach, you end up with a lot of templates. And they are maybe very hard to manage by the end. So that's at least my experience, because I once had to migrate the Jakarta Faces application to Timeleaf because they wanted to switch from Jakarta E to Spring and didn't want to stick with Jakarta Faces, and that was a pain because the application was much more complicated by the end. But this really depends on what type of application you're doing. And on the server side, you have a controller, so that's a Spring Bean, and the get mapping that gets a model. And then you add attributes to the model, and here we see another problem because this is not type safe, right? Because if I have a type point attribute key, then the template will render but not find that. Probably you will not even get an error message. On the other hand, and that's why I've chosen Qute for the demo as well, Qute also uses HTML templates. But on the other hand, Qute has a concept of so-called checked templates. So you define like a static native, so it's like a misuse, in my opinion, a bit of this native stuff there. But with this template instance, you don't have a model where you set values. You more have like a template where you can call a method on it, right? So if you look at the get mapping for the hello, you see that this is returning a template instance. And I just use templates hello as a method and pass world as the value this time. So it's kind of type safe, so it also compiles. That means if I make a mistake here in the template, for example, my code will not compile because Qute will check if the template matches the definition with the check template that I have here in my code. So I get some more type safety. On the other hand, I forget to tell that why I use JT. J2E, as I said, stands for Java Template Engine, and this is compiled. You probably still know JSP, Java Server Pages. Java Server Pages also compiles either at compile time or at runtime to a servlet. And JT does the same. And because it's compiled and it's not rendering during runtime, it's much faster if you have like certain performance requirements. I would go with JT. The problem with J2E is a bit, it will not be kind of HTML compliant template at the end. It looks like here, but if you're starting to do nesting or doing templates with some fragments, for example, it will no longer be valid HTML code. So you need a plugin to work on the templates, for example, in IntelliJ, but that's also provided by JT. Now, that's fine because that's very simple to implement in each technology, but the question is, what do we do with dynamic stuff? Because UIs must be dynamic, right? And maybe you already noticed that, but my UI in all implementations is dynamic. So I reload the data during scrolling, for example, because I don't know how many products that I have, but it simply doesn't make sense to load all data, right? Even at the beginning of web development, we had issues with that because a table, a HTML table, could only have a certain size. Other than that, the browser would have problems or would require a lot of memory, so we couldn't do that. And then we had this paging with the buttons, right? Next, 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 but next is a bit not so, in my opinion, not so nice to use. And first and last page doesn't make sense, right? At least the last page. Who knows what's on the last page? So you never go there. So it's much better to reload the data or lazy load the data during scrolling, right? And if you're using Vaadin, this is built in because the Vaadin grid knows is able to do that without a problem. So that's a feature. I mean, we also have like sorting. We could add filtering. We could even, I didn't configure that, but we could reorder the columns in the table. We could store the order of the table. We could hide the columns, for example, something like that. And that's the benefit of components, right? Because this Vaadin grid can do that out of the box. You don't have to write a single line of code. You just have to configure it, and then it works, right? And the same is true for prime faces, because here we have the faces example, and I'm using prime faces, and the grid here is also lazy loaded. I'm curious why this, just a demo, right? But here we have templates, JT and Qute, and now how can we do that here? Because I also do that. The difference here is between the Vaadin one and this one is It just scrolls and reloads, but the data stays in the page, right? So if I go up, the data is still there. That means the DOM grows. On that side, nothing grows because the table is kind of a virtual table and just keeps the data that is really visible, or maybe what's visible and some data before and some data after, so this saves memory on the client side, right? And to do that with Faces or with the template engines, it's a bit more difficult, but Jakarta Faces has that built in since 2009, and it was called Ajax Request or Ajax Enabled Jakarta Faces. And what we could do is we could just add there like a tag called fAjax and then say, okay, if the name input is executed, we render the output. And so this will not do a full page reload. This will do just a post request and get back just the data that is needed to replace there, right? And all the other frameworks didn't have that back in the days, but lately there was a framework introduced called HTMX. And that's kind of an HTML extension, and the idea is you want to have dynamic behavior in your server-side rendered template. By the way, it doesn't matter if this is Java with Spring or PHP or Ruby on Rails or ASP.NET or something very old. This works with everything, but you can add dynamic behavior to your website. You could even integrate that in a single website, and then you could use these Ajax attributes like get, trigger, and target. And what it does here is if you hit the button, it will execute a GET request to the path API hello, and it will be triggered by a click on the button, and the target of the result will get rendered in the div with the ID result, right? You could do that with JavaScript. You know, we had jQuery back in the days. I do JavaScript development since 1997, and I could do that with a few lines of code. That's not that hard, but a lot of people can't do that and won't do that. And HTMX really integrates very well, and it's easy to use, more or less. So there are a lot of different aspects there. But let's have a look at the implementation. Let's take which one? Qute. And here we have like the templates. And for the products to scroll, I have a products template. And this products template here has the form. That's not relevant in that case, but we have a table here, product table with the header. And then we include kind of the product rows. And here the product row is doing paging. So we have this next page. So we are looping over the products. And then if we see that the index of the loop, so the product index is kind of an attribute that I get from JT, what's the index of this product currently. And if this is the last index in terms of the table size that I have, I trigger a paging. So that means the last row on the page gets this HTMX attributes, and if I scroll past this last row, or I try to scroll past this last row, it will execute a GET request with the products paging with the size and the page, and this one here will then return where we have it paging. This will return just the template products rows with some data inside, right? You see how it works? So it's quite simple. So we could use HTMX on any HTML attribute. So you can have a div clickable, a span clickable, you could have a table clickable, you could add all these events and the event handling to every attribute that you want to. And this sounds very nice, right? But it also have some disadvantages, because you will have to split your whole template into smaller fragments, right? Because you want to return the fragments, not the whole HTML page. And managing these fragments, if you have a lot of dynamics on the web pages that you're building, there needs some upfront thinking how you want to organize that to finally find out which fragment is used for which part of your application. Because a friend of mine is working for a university, and they were building the grading system completely new. So it was a Carterfaces application before. They did a modernization. Now it's built with Spring Boot, but with HTMX. And they decided to do everything dynamic. So they have inline editing in grids, for example. They have the scrolling. They have other parts that are dynamic. And they ended up with a few hundreds of these fragments, and they had to refactor the application during the development because they had issues with organizing the fragments and couldn't find out which is still used and whatnot. So that's a bit the downside of the HTMX approach. So to conclude, in my opinion, full stack development can be more efficient. So because you're working on the whole application, not on only one part, you don't have handovers and communication, right? And communication and handovers take time, right? And is breaking your speed during development. And the best thing about that, the web frameworks are very, very mature. So Jakarta Faces is from I can't remember, maybe from 2003, I would say, or 2002. Vaadin is from 2001. Spring MVC is from 2004. And yeah. And finally, we have HTMX, so you can use dynamic templates everywhere if you have HTML templates. So nothing stops you from application doing full stack development. That's it. Thank you very much. Are there any questions?